So, let's look at material selection first. Choosing the right material is not an easy task, as there are over 60,000 wood species in the world. Project materials are usually chosen based on initial investment and appearance, but other factors should also be considered, including climate, maintenance needs and costs, performance over time, and compatibility with local culture and aesthetics. Designers and investors should talk about acceptable changes to the appearance of wood at the beginning of the project and choose materials that reflect those expectations, selecting a material that changes minimally or in a way that is acceptable to owners. When predicting the performance of wood over time, there are two important factors to consider: the material's natural characteristics or resistance and the exposure to changing climate, moisture, and temperature conditions. The natural ability of wood to resist decay and insect attack is known as durability. To determine the durability of a wood, each type of wood is classified into a durability class, which indicates how long it should last in a particular environment. The European standard EN 350 classifies solid wood and wood-based products into durability classes based on their resistance to fungal decay, beetles, termites, and marine organisms. There are 5 durability classes for decay, ranging from very durable to not durable. In general, hardwood is more durable than softwood. Deciduous hardwoods grow more slowly and are denser, stronger, and more durable, but they are also more expensive. Evergreen softwoods, like conifers, on the other hand, are fast-growing and less durable, but less expensive and widely available. Durability classes are determined by testing stakes made from the heartwood, the center of the tree, stuck into the ground and observed over time. Heartwood is the older and dead part of the wood that is usually darker in color and more durable. The outer young living layer of the wood is called sapwood. Sapwood is softer and less resistant to decay than heartwood and is therefore not considered durable, even if it comes from an otherwise durable species. The European standard EN 350 defines 2 durability classes for beetles and 3 for termites and marine borers. The heartwood of many European wood species is naturally resistant to wood-boring insects, except for termites, so materials used in termite-infested areas need additional treatment and protection. Unfortunately, most European wood species are not durable enough for outdoor use, and durable tropical species are not a sustainable solution due to deforestation and longer transportation. So scientists and manufacturers are trying to make locally sourced wood more dimensionally stable and resistant to decay. An effective, healthy, and environmentally friendly way to do this is by wood modification, a set of procedures that change the composition of wood and influence its properties. These include thermal treatments, densification, impregnation, and chemical processes such as acetylation and phosphorylation. Let's look at some examples of natural wood species when new and after being exposed to weathering for 15 months. Now, let's see how these species look when they are treated with different wood modification techniques, and how these samples age and look very different from untreated wood. Modified wood is not only more resistant to decay and weathering, but can also effectively repel insects by making the wood less attractive and harder to digest. Another solution that offers improved mechanical properties is wood-based composites. Engineered wood is a great innovation that has been gaining popularity over the last years, especially in the context of tall timber construction. By combining layers of timber and other materials, engineered wood products like cross-laminated timber, glue-lam, oriented strand boards, wood plastic composites, and many others allow us to use smaller trees and waste from wood processing, make the material stronger, more uniform, and more pliable, and expand its potential uses. While certain wood species and modified lumber offer greater durability, they tend to be more expensive than available but less durable softwoods. Also, not every project needs very durable wood. The second factor to consider when selecting wood for a project is the environment and situation to which wood and the wood-based products are exposed. These situations are described in the European Standard EN 335 and defined as 5 use classes. The first use class refers to situations where wood is inside and under no risk of getting wet. Examples include floor joists, floorboards, or internal joinery. Wood in the second use class is either inside or outside under cover and not exposed to the weather. However, it is possible that it may occasionally get wet due to condensation. The third use class covers all outdoor applications that are above ground and exposed to rain. These include cladding, or the outermost layer of the facade, window frames, outdoor furniture, fence rails, and much more. Wood in the fourth use class is not only exposed to the weather, but also in direct contact with the ground or fresh water, like fence posts or decking that is sunk into the soil. Finally, the fifth and most demanding use class consists of wooden products that are in regular contact with seawater. Applications where there is little risk of rot don't need to use very durable wood, but the higher the use class, the more durable species and greater protection are required.